Hello, everybody, and welcome to week 13 of our online astronomy course. Hope you all had a good Thanksgiving, had your fill of turkey and stuffing, and now it's time to enter the last 2 weeks, the last 2 modules of our online astronomy course. So we're moving into module 13, but before I get to that, I want to tell you a little bit about the final part of the course. And I know this is a really busy time of year. Thanksgiving has just ended. We're moving into the holiday season, Christmas, and it's just a busy time. And I want to help free up the time. I know you have other exams to take, other final exams. So I want to free up some time for you. And so what I'm going to do is to open up the final exam, the constellation quiz, and the signature assignment. I'll open those up tomorrow, and you can do them anytime from tomorrow until the official end of the course. So the modules are open. All the modules are open, so you can work ahead and do those. And then anytime you want to, you can take the final exam, the constellation quiz, and the signature assignment. Let me just say a few words about them. The final exam is not comprehensive. It's just like any of your other exams, 35 multiple choice questions, open book for the exams. The constellation quiz is just 15 questions. I show you a constellation and you just multiple choice, tell me what the name of it. You don't have to spell the constellations. You don't have to know any of the bright stars in the constellations. You just have to recognize the constellation. Now, the constellation quiz is closed book. And as long as you study for that and you give it some serious attention, you'll do fine. Most people get 100% on it. The third thing is your signature assignment. That is just a short paragraph you have to write. You have to answer a question, and that question is, it's as though a friend asks you. If a friend asks you, how does an astronomer think about the universe? This is what you would tell your friend. Don't tell me what I want to know. Tell me how you would answer your friend. And just answer that in a short paragraph and submit that. That's worth 5 points, and that's 5 points total points of your total of 100 points for the class. So it's half a letter grade. So be sure and do that. So starting tomorrow, I'll open up final exam and the constellation quiz and the signature assignment for you to do anytime you want to. And I'll also be sending out an email giving you more details about what I just said and about the constellation quiz. So here we go into module 13, and the module 13 is about the other galaxies that make up our universe. And it's really amazing because it's not even been 100 years that we've known that there are other galaxies other than our own Milky Way galaxy. 100 years ago, people thought that our Milky Way galaxy was the only galaxy in the universe. It was the universe. And we saw these other faint smudges in the sky, and we'd look at them, and you couldn't tell if they were some, small little globs and dust that were just within our own galaxy, or if they were huge collections of things, of stars that were far outside our galaxy. And there was a big debate about that. And that was finally settled in 1923 when Edwin Hubble discovered a Cepheid variable star in the Andromeda Galaxy. And using the period luminosity relation of Henrietta Swan-Leavitt, he determined that that galaxy, M31, the Andromeda Galaxy that you see behind me here, is 2.5 million light years away from us. And that is far outside our own galaxy. And all of a sudden, people realize that these little smudges were all other galaxies located far outside, and our universe was filled with galaxies. And there are different types of galaxies they found out. Some are spiral galaxies, like our own Milky Way galaxy, or the Andromeda Galaxy. Here, let me move aside a little bit so you can see the, whoops, maybe I'll move the other way. There we go. You can see the bright galaxy, the bright nucleus of our Andromeda Galaxy. And I say our galaxy because the Andromeda Galaxy and our Milky Way are actually moving toward each other. And about 4 or 5 billion years from now, they're going to collide with each other. Now, the stars aren't going to hit each other. The stars are much too far apart. So when the two galaxies collide, the stars will just pass by each other, but the gas and dust that's within the galaxies will collide. And that gas will heat up and there'll be a big burst of new star formation. It will be spectacular fireworks in about 4 or 5 billion years from now. So something to look forward to, maybe. But there are spiral galaxies like our own. There are big football-shaped assemblages of many stars. Those are called elliptical galaxies. And then there are irregularly shaped galaxies that have no real definite shape to them. And so those are the 3 types of galaxies that there are. Now, we need a new yardstick to talk about the distances between galaxies. Now, when we were talking about the distances between stars, the distance from our sun to the next nearest star, Proxima Centauri, is only about 4 light years. That's about a parsec away. A parsec, remember, is 3.26 light years away. So distances between stars are measured in parsecs. Now, distances within our Milky Way galaxy, our sun is about 8,000 parsecs, 8 kiloparsecs from the center of our galaxy. And so distances within galaxies are measured in kiloparsecs. But as I just told you, the Andromeda Galaxy is 2.5 million light years away. And so we need a new measurement. We measure distances between galaxies in terms of millions of parsecs. A million parsecs, a megaparsec, is about 3,260,000 light years. And so the Andromeda Galaxy is a little under a megaparsec away from us. It is the nearest large galaxy to our own Milky Way. And you'll learn about how galaxies are arranged in clusters. Now, our Milky Way and Andromeda belong to a relatively poor cluster of galaxies. And poor just means have only a few members, like 40 members, and that's called our local group of galaxies. So congratulations, you're a member of our local group of galaxies. There are other much larger, richer clusters of galaxies, like the Virgo cluster. That is about 16 million parsecs away, 16 megaparsecs away from us. And these large clusters of galaxies are arranged into larger groups of clusters called superclusters. And those are even arranged into a pattern that fills our universe. And so you'll be learning all about that. One other thing you'll be learning about, and that you may have suspected from my talking about the Milky Way and Andromeda colliding, is that galaxies are not island universe that just float out in space, separated from each other. Galaxy collisions are really very common. And what happens is that when 2 galaxies collide, although the stars pass through each other, their gravity slowly pulls them together, so they merge together. Just like after our galaxy in the Milky Way, our galaxy and Andromeda merge together, they will merge into a single large galaxy. So these mergers are sometimes called galactic cannibalism, because galaxies devour each other. And our galaxies have probably devoured, other galaxies in the past. And we have evidence of that in the shape of our Milky Way. Now, one other thing I want to tell you about the galaxies, and that is, except for galaxies that are gravitationally collected within a group, like the 40 galaxies or so, 40 or so galaxies in our local group are gravitationally attracting each other. But outside of galaxies like that, once you get to galaxies that are greatly enough separated, all the galaxies in the universe are moving away from all of the other galaxies in the universe. And not just moving away in any, in any sort of pattern, they're all moving away so that galaxies that are twice as far away from each other are moving away from each other twice as fast. And that's the sort of expansion. This is called, by the way, the expansion of the universe. And it was discovered by Edwin Hubble. The expansion of the universe is the same sort of expansion that happens when you stretch a rubber band. So here I have 4 rubber bands that are linked together, and the knots, the knots here represent galaxies. And there's also, you can imagine there's also a galaxy at the 2 ends where my fingers are. And so the galaxies are expanding like this. Now I'm going to try to hold that one galaxy in the middle, and you can see how the other galaxies are moving away from it. But let's put ourselves, let's let this galaxy right here on the left end be our Milky Way galaxy. And I'm going to look along that galaxy. I'm going to watch the other galaxies moving away from us. So I'm not going to move this galaxy because we're here at rest. We're just sitting inside our galaxy. We're watching the other galaxies move away from us. And watch what happens. What do we see? Watch what happens here. We see the other galaxies moving away, just like that. Let me do that. Let me do that again. Those other galaxies are moving away. And as you watch them move away, I think you can see that galaxies that are further from the Milky Way are moving away faster. And in fact, galaxies that are twice as far away from me are moving away twice as fast. Let me show you that a little bit more precisely. Again, this galaxy right here, where my fingers are, that galaxy is going to be the Milky Way, and I'm going to hold that right at the left side of the screen. And I'm going to move these other galaxies away from it. So this galaxy, our Milky Way, is not going to move. I'm going to move these other galaxies away from it. Now, this galaxy I'm holding here between my right fingertips, here on the right side of the chain of rubber bands, is right about in the middle of the screen. So I'm going to stretch it all the way over to the right edge of the screen. Watch what happens to that middle galaxy here, the one that's in the middle of the chain. So here we go. I'm going to stretch this galaxy here at the right end all the way over. Watch what happens to the galaxy that's in the middle there. Here we go. So I've stretched these galaxies out. And maybe you can see that what's going on here, I'll do it again, is that although this galaxy right here that I'm holding here in the middle has moved across half the distance of the screen, it's moved over to the far edge, this middle galaxy, the one right here, that middle galaxy didn't move half the width of the screen. It only moved over to the middle of the screen. So watch again. It just, oops, I moved the wrong one. That just moved over to the middle of the screen. So it only moved half as far as the galaxy I'm holding here on the right end. So these fingers over here on the left are the Milky Way. This galaxy that I'm holding on the right are twice as far away as the middle galaxy. And as they expand, it's moving away from me in the Milky Way twice as fast. Twice as fast. So the whole universe is expanding the same way rubber bands do. And although this rubber band chain just has a certain number of rubber bands in it, the galaxies could go on forever. And so I would see the same thing regardless of which galaxy I held over here on the left side of the screen. And so all the galaxies see the same expansion of the universe. All the galaxies see other galaxies that are twice as far away, moving away from them, twice as fast. That is the expansion of the universe, and we describe it using the Hubble constant. The Hubble constant tells exactly how fast something is going if we know its distance. And it turns out that galaxies that are a megaparsec away from us are moving away at 70 kilometers per second. Galaxies that are twice as far away, 140. I'm sorry, galaxies that are twice as far away, meaning 2 megaparsecs, are moving away at twice 70 or 140 kilometers a second. So for every extra megaparsec of distance, you add on another 70 kilometers per second of speed. That's called the Hubble law. You'll read all about that in your module, and I've worked out some sample calculations in the module introduction. Finally, I want to show you where you can look in the sky to see the Andromeda Galaxy. So to do that, let me pull up Stellarium here. Andromeda is the farthest thing you can see with your naked eye. So if you go out some night this week, we're approaching the new moon. The new moon is going to be next Saturday. So the skies are going to be dark. The moon is setting very early. And this just happens to be on Wednesday, December 1st. But you'd see the same thing any night this week. Just go out. This is about at 10 at night, face west. And you're going to be looking almost straight up. So just turn your head upwards, tilt your head upwards, and keep going. And you'll see, if the skies are dark, and you have to be under dark skies to see this, a little smudge in the sky. And if you have binoculars, you can zoom in on that smudge. And right there is the Andromeda Galaxy. Now it's fairly large, but it's very dim, and so that's why you have trouble seeing it. But if you're out under a dark sky and you see it with your naked eye, I think that's really special, because that means you're looking at light that left the Andromeda Galaxy 2.5 million years ago. So go out, try to see the Andromeda Galaxy, get yourself under some dark lights. If you're in Ogden, go back to Pine View or something like that, or out to where it's dark, and take a look. And here I'll just zoom back out again. There we go. I'll come back down to the west. And you know, if you can't find Andromeda, you can always pivot around and look east. And there you'll see Orion. And you can look up above Orion and see the Pleiades star cluster. And around the bright red star, the red giant Aldebaran, you can see the Hyades star cluster. So I hope you enjoy learning about this amazing universe that we live in. And next week, we'll learn how it all got started and how the whole universe developed from an initial very hot, dense state and expanded into what we now know is our present universe. And that process, that expansion from a very hot, dense beginning, is called the Big Bang. We'll find out about that in Module 14. So until then, I hope you have a great week. If you have any questions, as always, just contact me in the discussions or send me an email, and I'll be happy to set up a Zoom meeting or meet with you in my office if you'd like. But until then, have a great week, and I'll see you next time. So until then, bye-bye.